Good morning, everyone. Is this working? Okay, good. Thank you. So, yeah, good morning. I'm Kari Tammi. Welcome to this Digital Twin seminar. In downstairs, when you subscribed, you got the program. I will not go through it in detail now, but the program paper has the titles and presenters, and on the back side, it has a map. There were so many people that we had to have this seminar in this building, and then the demonstrations in K3 building in Puumiehenkuja, and I hope that there are not too many people in K3 building at the moment. Yeah, we tried to do our best to tell that it starts and the seminar session continues in this building in T1 hall. And then all the demonstrations are in K3 and as well as food. And we'll come back to those details later. Juha Takkunen, CEO of IDEAL PLM, kindly volunteered to give the opening speech tomorrow, and I'll hand over the mic to Juha. Thank you.
Thank you, Kari. Very warm welcome to all you from my side also, and it's a pleasure to see so many people here. So digitalization changes everything. It's a mantra I think we are hearing all the time in the news and media. But it's a fact. It's happening all the time. It has been happening. It's changing our way of living constantly. The way how we are buying things, how we are traveling, how I think many things are happening, and how manufacturing companies, they are manufacturing the products. I think that's changing also heavily, and how those products are connected to internet and to other products. And the fact is that during the last 20 years, from the Fortune 500 companies, half of those companies, they have been disappearing. And the main reason is that digitalization. They have not been able to innovate new things, and other companies, they have been disrupting their business, and those companies, they have been going to bankrupt or they have been just losing the business. I have a couple of examples here. So if you are looking into history, music industry, playing music, vinyl disc used to be the main media, how to provide the music in the still I think mid-90s. Then became digital solution, compact disc. It was a huge advantage in those days. It was much smaller, but still required some device how to play the music. And nowadays, I think almost everyone is streaming the music from the internet. So it's the total disruption in the way how we are consuming or using this music, and also I think how the music business is going. And same thing, taking photographs. So I think Kodak, it's very well-known example of this disruption. One of those companies which has been disappearing during the last 20 years. So for 100 years, I think using film was the main way how to take the pictures. Then became digital solution, digital cameras, and those photos they were saved to CDs. And nowadays, I think almost any device is having a camera, and those photos are saved to somewhere cloud applications. And the funny thing in this story is that Kodak, they used to have the patent for this digital camera, but they were not willing to use that one, disrupt the business. They were just waiting that 25 years and hold it that in a secret, that patent. And when it was opened, other companies, they were starting to do this business, and Kodak was killed. And if you are looking at this manufacturing industry, the same thing is happening here, and that's one of the reasons why we are here today. So still in the 90s, I think the drawing board, it was the main way how to design different things, paper, pens, manually doing things. Then became a 2D CAD systems and 3D CAD systems, I think late 80s, early 90s. And also some level of data management systems, so early PDM systems. And nowadays, digital twin and the PLM is the way of working for advanced companies to get benefit of whole this chain. And I think the target is to create this digital twin of all the products and production, and also I think the end product, and that's the way how to get the advantage in the competition, heavy competition. And I think today there will be a lot of presentations in this area, so I don't go any detail. But it's a good example how things are changing. So my message is that if you do not disrupt yourself, you will be disrupted. And that's the reason why this ecosystem and this teaching in this area, it's extremely important for all of us, for Finnish economy, so that we are able to keep this standard of living and way of living what we are having currently. I wish very eye-opening, enjoyable day to all of you. Thank you and welcome.
Thank you, Juha. Any questions to Juha? Okay, if no.
I will be here all day, so if there is something, just come and discuss with me.
Yes, Juha will be here whole day, so please discuss with him later. Regarding questions, one thing I try to now remind, and please presenters try to remember when you get the question, or if you get the question, please repeat it, because we are actually streaming this occasion, and even the presenter hears the question. It is better to repeat so that also the streaming will get the question. So all the presenters, please try to remember to repeat the question and then answer the question. Unfortunately, we didn't get the practice now. It's me next in row. I give maybe this is also a bit of a type of an opening speech, and then we'll go really to the substance. But yeah, first of all, I'm Kari Tammi. I'm mechatronics professor in Aalto, and we have this Business Finland funded project called Digital Twin. It's 2-year project, and you actually saw the company logos in previous slide. And I tried to think my career, and I never been a project seminar regarding one single project that has 160 subscribers. I think typical project seminars are order of tens of people or something. Then it's different if you have a program or something. But it seems that this digital twin is some type of password or trendy word now. And the title of my presentation comes actually lecture in Professor Mäntylä's class. I was giving a talk there about digital twins, and I try to say that either you use some engineering and statistic-based methods, or you use witchcraft, and we try to replace engineering witchcraft, meaning kind of like a tacit knowledge and partially experience from years. So we try to replace it by using data and modern tools. Okay, going back to that password. So IEEE just listed trends, and there were like 10 technology trends, and then there were more like commercially affiliated trends. and digital twin happened to be first one in here in commercial sense. I think I slightly disagree with the definition or the way they see it, but anyway, it seems to be quite important, and maybe that is part of thing which explains how people are interested in it. But I think if you go to that website and check, those trends were quite interesting actually. So then, okay, if you think about IEEE, they were kind of like not so radical compared to Finnish media. So there is quite strong value promise that digital twin will save Finnish companies. So there is quite a lot of things in media, and I kind of feel a little bit weight in my shoulder after this topic. So I try to cover here questions: why we do these digital twins, what they are, and how you do those, and I guess you will get very different explanations. Already Juha Takkunen's presentation, I think it has a little bit different view, and last autumn we visited Mevea's seminar, and they also explained digital twin in a little bit different way. I'm not trying to say that someone is wrong or someone is right actually, but this is maybe, I guess its question is how much you put like design engineering emphasis, how much you put manufacturing emphasis, how much you put product lifecycle emphasis in the loop. So obviously we are not, even this is fun, we are not doing it only for fun. Like IEEE already said that there is a huge business potential. But then there are kind of like very, very traditional explanations. So to improve product safety, performance, capacity. So I would say that it's just usual Citius, Altius, Fortius. And like I tried to explain, as long as we don't have crystal ball, we better develop digital twins. So this happens, like Juha already showed, that physical and digital world, they merge, and now you will have quite many definitions for digital twins. Is it only like physical part of the, I mean, the physical phenomena described in a digital model, or is it something more? And I very much liked our doctoral student Juuso Autiosalo's definition that it's a cyber part of cyber physical system. So we want to implement physics, connect it, maybe some data, maybe some social media, something very non-physical, but still like existing and practical data. Then I just wanted to remind that like our cars are full of different surveillance systems. So every day when you switch ignition on, you will have some check lights there, and if the signals are not matching, then it will turn on the engine light or turn on some other light. So this is very much existing in small extent, but it's coming also. It's going to exist in wide extent, because these things are mostly now still inside the car or inside your consumer product. So, and there are quite many challenges. How you really realize them in your particular application, and how you scale it up. So previous vehicle example. Every year, nearly 100 million cars are made. So will you have like 100 million digital twins annually? and who will maintain them. Hopefully our demo day and ideas will answer how you implement these and how you maintain and then overall how you make a clever business out of this. And I'll close with the picture of our project proposal. We are very much working in industrial environment and the crane donated to Aalto is in the core of our thinking in digital twin. So thank you for listening and thank you for coming, and I'll close my program, my part of here. If you have any questions, I still have a couple of minutes to answer. Thank you. Okay, please, Tatu.
Maybe one question about the definition that the cyber part of the cyber physical systems. What if so? I think the physical there is quite important. That you cannot have a digital twin of a digital object like the software, or can you? So because these real world objects are becoming more and more digital themselves. Where is the limit when the digital object is already too digital for digital twin?
And now I'm supposed to repeat this question. Thank you for the question. So when I think the question was that how there is so much software and digital things in physical products, and now we are making a replicate of the whole product itself. And now there are like digital twins of digital part and then the physical part. And yeah, I think this is very good question, and we face to this problem in quite many places. When let's say we are assessing a performance, in past of my career we did a lot of energy efficiency analysis for ships, for instance. There is like a machinery, there is automation system, and there is lots of human intervention. And how do you make a digital twin of this everything? It's challenge, I think maybe you start from the subsystems and try to be happy with partial descriptions, so that every now and then there are like you try to make a model of everything, and then usually you screw it up somehow in order to have a model too complex or too inaccurate. Thank you. Now it's time to go forward, and I'll be the speechman of today, and I'll invite Valtteri Peltoranta here. He's senior reliability engineer at Konecranes, and he speaks about how does IoT data transform engineering. So please, Valtteri.
Thanks, Kari. Good morning, everyone. I'm Valtteri Peltoranta, and I'm really happy to be here today to present to you how Konecranes sees digital twin and what kind of approach we took in our common project. You look nice, by the way. For the project, we took the main target area, the engineering, how we develop products, and we wanted to challenge the assumptions that we usually have in product development. They usually start by reading standards and books related to the crane industry and having knowledge from early experience. But we wanted really to utilize the data from the field to challenge these assumptions. So of course, following the crane engineering, there is first the physical crane, the actual product, and the customer starts to use the product in their own way. And then we have all the different technologies to collect the data from the customer cranes. So we get the usage data, we get the faults, we get the alerts, and we also get the service history from the products. So utilizing all that data by analyzing it in different ways and collecting the new information to the digital twin. This is the loop that is now created to really challenge the traditional way of developing products. So we wanted to create this feedback loop back to the engineering, so that the engineers really know how the products behave in the field and how the products could be optimized and new products developed. So more about the really solution approach. So we chose to have the digital twin in the PLM system as the approach by collecting the data from the field back to the PLM. And the reason was that the engineers are working in the PLM systems. So it really supports their daily work to get the data back there. So there is, of course, the product itself with the structure, all the components and the 3D models and the drawings. And then there is the actual product, the physical realization. Later today you will see the Ilmatar crane in the lab representing the physical realization. And there are the sensors collecting the condition monitoring information and the usage of the crane. And then we also have the service who takes care that the product is up and running, and they record all the different faults and repairs for the product. And when we feed back that information to the analysis and compare what was really designed and then what was the reality, how the product behaved and what kind of, let's say, problems there may occur, we will then make new information for better engineering. And this was mainly the way we approached the project. Of course, every company selects their own way of implementing the digital twin, because digital twin cannot be everything for one company. Every company selects what are their business needs and what kind of attributes the digital twin should have. And looking at the digital twin, how it's constructed, if we think about a crane, it's designed based from several components which behave differently in the field. So every component sees the usage in a bit different way. So all the stresses in the field, it depends on the component how it behaves there. So we took the product structure as the starting point and thinking about the different components. What is their status and estimation based on the collected field data? So some components may be still working in a really good manner. Some may have early indication of something happening there, possibly a starting wear, for example, and then some components may be even in a faulty state. And this is also the way that the engineers design the product. They start from the components, so of course they want to see how the different components behave. So thinking about how the PLM now bridges the gap between the real world We took our existing data systems for the IoT data and the service data, and then created together with Aalto and other companies, the needed analysis to bridge the gap and create the information, which is the main content of our digital twin. So what kind of information we can bring out with this new approach? Thinking about the Konecranes business, both the service and the engineering business really benefit from the new information. So service, of course, want to have as well predicted maintenance tasks for the product as possible. So in a way we can utilize the analyzed component information to create this kind of digital twin based maintenance. So we predict what are the needed maintenance tasks and inspections for the product that we have all the information. And then on thinking about the engineering view, we can compare what was designed and what was really realized in the field, and finding the weak points of the products. And that was the approach for optimizing the dimensioning and selection of components. And later today you will see how Juuso Autiosalo will present the practical demonstration of this in the lab. Few words about the graph here, about what kind of information we now in the first demonstration try to achieve. We have the graph showing the realized usage and what the component has seen in the field and what was really designed during the product development. And then by comparing the realized and the designed, the designer can then think, was the component selection right in the first place, and how could I optimize it with this information? Of course, it's not about the single asset, single product. The design of a product family and a volume product cannot be based on data from one customer crane. So we have to think about the statistical view of digital twins. So we will have several digital twins in the field, and some customers are using the crane really heavily and some in a more light manner. And then we have to understand what are really the customer needs, how it varies depending on the industry and inside the customer population, so that we will really have best fit for the varying customer needs. So we have to find the similar parts in the field. That's also why we need really to have the product structure as one of the key points of the digital twin. Then equalizing the data from the different cranes and analyzing all the whole population in statistical manner. And this approach will also be part of our work during this year together with Aalto and other companies presenting today. A few more words about the use case that we choose. We had a traditional design task, how to select a bearing for a mechanical component. You can see there a crane hook there, and we have some basic raw data from the usage. We have the information from the load sensor, what kind of loads are lifted, And then we have the information how the hook is moving there when the customer uses the crane. So we have also the position information. And by the way, the bearing is here inside the rope sheave, and 2 different rope sheaves there. So we have to process the data a bit more from the raw data to fit our engineering task. So we then inside our solution that you will see today, we calculated the rope forces and then the bearing rotations, how many rotations each of the bearing had. And then we also have the design criteria, what bearing was actually selected in the first place and what was the capacity of the product. And then creating the analysis that what was really collected from the field, what were the loads that were lifted and how the hook really moved there, and what was originally designed. We can then close the gap and have the new information about the bearing status and how well the design really fit for the purpose. And of course, in a similar manner, we will now expand for all the components in crane. So there are also electrical and electromechanical components, but the idea is the same. How the selection was based in the first place and how it really behaved in the field. Conclusions about the whole digital twin, what we can achieve. We can really make a cultural revolution in engineering and in other businesses by utilizing IoT and digital twins. In this project we try to get from the traditional assumptions to real-world information, so that the design really fits the purpose. And one of the key points is that it will connect the engineering and the service business and also the customer more tightly together, because there is the real data from the products to support all the discussion and decisions. So when we feed back the information back to the product and the digital twin, it will help all the different stakeholders. And then there's also the approach of continuous learning, when we get new data every day. And of course there are challenges also. In crane industry, for example, the raw data may vary from asset to another, and we have to have methods to really formalize it in a similar manner so that we can utilize it widely. And all the data does not fit directly to make the business or engineering decisions, so we need really a lot of developing also in the methods of how we process and analyze the data. And then there are also the customers who are used to refer to these assumptions and standards. So the machine manufacturer has to really gather a lot of knowledge to have good arguments for all the customers that how we are making things in a new way. And this was the way that Konecranes chose to approach digital twin and how the tasks have been defined in the project. Thanks a lot for listening. That was all that I had. Any questions? Yeah, go ahead. Yeah, we have a lot of ways of collecting the data. Usually the cranes have a condition monitoring unit and a modem collecting, for example, the usage parameters. Then we have different sensor solutions for collecting the condition monitoring data. And then, of course, thinking about all the other data, we have, for example, the service reporting system to collect all the service tasks for the product. So it depends on the product, but I would say that the technological solution for collecting the data is not the challenge. It's how to bring all the data from the different systems together in a unified manner. Go ahead.
As we know that weld quality has a big effect for the fatigue life of cranes. Have you thought that you should like somehow collect data while you are welding cranes, or you somehow scan the actual crane after welding?
Yeah, the question was that some of the manufacturing attributes have an effect on the strength of the parts. For example, how welds affect to the lifetime of mechanical part, and should we scan or record data during the manufacturing? I would say yes, definitely. Manufacturing, how the product was manufactured and how it behaved in the field, they really connect together. But still there is a lot to do in the manufacturing part also, but it's on our roadmap, I would say, to really collect, for example, the data, how the parts are machined and how they are, for example, welded. So yeah, good point to bring out. Thanks. One more there.
So how much can you utilize these IoT and digital twins in your sales arguments? Is it a sales point that you can differentiate from the competition, or and how? What are you selling more?
Yeah. So I think you probably heard the question how we can utilize the digital twin and data in sales. It's challenging, I would say. Of course, that's the target that we are doing, but like said in the last slide, when customers are used to refer to the traditional way of, let's say, for example, having a duty class selection based on standards, what kind of crane they need, we then really need to show the data to the customers that, hey, this is how customers like you use the product, and that's the reason that we will choose this product for you. So I would say it's also developing the way how to discuss together with the customer with all the new data and the digital twins.
Okay, let's give a big hand to Valtteri.
Thanks.
Thank you, Valtteri, and thank you for very good questions. The next presenter will be Ville Pantsar. He's the director of digital processes at IDEAL PLM, and his topic is how does digital twin evolve across its life cycle. So we probably now hear a little bit more like life cycle perspective, as I mentioned earlier. But please, Ville.
Okay. Does this work? Do you hear? Noni? Okay. Yes. So, hello everybody. It's nice to see all of you here, and also with the live stream, and later on with the offline stream. So hi to you also. We have now discussed about the digital twin, about the hype word around it, and Valtteri's presentation was an excellent example of that now we start to ground that hype to reality. it's not anymore kind of hype word, even though it's in some hype curve and some stage. But now we really can see the benefits. We can really develop things around that, concrete things, concrete business things. So I'm a little bit talking about the point of view of the structure. Valtteri pointed out nicely that when you get the data back to the PLM, engineers can utilize that. Yes. But then there are, of course, some buts. Because you need to have some connection all the way to the original R&D phase, meaning that you are able to trace the decisions and how the product has been formed during its lifetime, so that you can actually then know that this crane, this data belongs to this product family had this kind of requirements coming from the market standards or somewhere else. And then combine, was the original thinking of the product matching, does it match with reality? With this slide, I think now that guy lost it totally. No, we can talk about this DNA. Let's jump a little bit away from the machine industry and machine design a bit, and a little bit look it from the different angle. So, from the nature, if we have parents have a child, of course there are DNA involved, then you know that there are 4 children, 1 child gets sick. Something happens, some kind of illness, heart condition or whatever that might be. Then of course the question is that is that something that one individual, that one person, it's the kind of happening only to her, it's coming from the living habits and the environment and that kind of thing, or is there something that is actually coming from the very foundation, meaning from the DNA, the genes? Then you need to go back and investigate, go to the mother and father and see that does the siblings might have the same thing. So this is actually quite easily to turn to technology and products. You have product families. Product families are built with the same principles, and then you have the assets in the use. So some asset might get failure or something happens at the site that might be due to the environment and the use. But if you want to go back, you get the data back to the PLM and you want to check that this is for sure something that belongs only to that one individual product. Then you need to kind of investigate the product family, the requirements, the foundations, the DNA of that. So let's go back for a little bit more technical stuff, more familiar to us. But that was kind of example showing in some way that this is also a little bit coming and replicating the nature itself. It's not only about that technology side. So we have a structure. We can take that this is now the structure of requirements for the product, for example. Then we might have the functional definition of the product, or let's say the same product in a different format. It might be the emblem or asset view or something else. You know that there are many kind of structures that the product during its lifetime start to see. First one might be let's say the full definition of whole product, including all the variants, all the components, and then the second one might be the configured structure, for example. That's why I didn't name all the structures itself. Then you have the, let's say, as built, as maintained structure. That is then something that is actually now at the field. And now if we little bit go back to the DNA part and start to combine these, you can see that we need to somehow link this information. There are a lot of information that needs to be linked so that you can actually then drill down all the way back to the original requirement of the product family and the product itself. And that's the quite easy analog for the DNA. It constructed. There is something that you need to link, somehow drill to the decisions done for the product in the engineering, in the R&D, during the delivery phase, order engineering, maybe, or something like that. Then this product evolution in digital platform. We can see that the product is evolving. You have a R&D project starting. You have the requirements coming from the market, from the business. You have standards. You have laws of physics, basically, that needs to be filled with the product. And then you capture these requirements and start to design and find the solution, what would be the best product in this case. Then you have the functional structure, meaning what kind of functions, how that operates, what kind of features. It need to lift something, it need to switch this light off when this happens, or you need to define in a way what the product does. And that needs to be linked also to the requirements. Then you have the logical structure, which is then defining, this is typically how the product looks. For example, crane, bridge crane. There are hoists, 1, 2, 3, typically in the crane. You have main girders, you have a walkways, you have a cubicle, somehow you need to get the power there. You have basic elements how that product is constructed, and those needs to be linked together in a way. And that needs to be then fulfill the functional structure, fulfill the requirements. And when all those are linked together in a way, then the engineers, electrical, mechanical, automation, software engineer can start to work, and they already have the linked information. Automation guy needs to know that this lamp needs to light on when this phenomenon happens. That is defined there. Electrical engineers can follow, okay, I need to provide somehow from the sensor this information that will happen. That mechanical engineer needs to have, I need to have the sensor, I need to fix it somehow to the product itself. They are working with the same environment, with the same structure that are connected together. That's basically the part of the product digital twin and the DNA in the PLM area. Then you start to manufacture it, bill of process, meaning that you split the product in a way that the manufacturing is able to proceed. So it's split into the manufacturing operations in a way. But that is still connected to these other structures. So you understand how and you can always review and go back with what has been designed and how that was planned. And then you have the as-built structure, outcome of the manufacturing, and of course the service bill of material, so that you know that service needs this kind of information, these are the spare parts and so on. That's kind of the connecting this digital twin to the physical counterpart, meaning that now you have the physical parts coming from the manufacturing with the serial number that is then connected to the digital twin, that is then tying the digital and physical world together. And then this as-built structure starts to live and can be called as maintained structure, and that is then that if their service technician goes and changes something, that needs to be also then linked to the digital twin, that now I have this new motor. Why that is important? Let's have an example. You have a crane, old crane with the old hoist, and then you take new hoist. You do modernization, for example, to the hoist. So you have a new hoist with that crane, and now you start to look at the IoT data, that the performance increased because there are no tear or wear, and it's completely new and able to provide all the needed torque cues and everything else. So it's kind of improved. If you don't know that this change was done, you can see the IoT data that there is now something really strange in the curve. So these kind of things we are now facing with this kind of closed loop PLM when we are connecting the information back, how to handle all these kind of cases so that we are able to analyze the data correctly. Then about the systems engineering part, I already explained that systems engineering, all the engineering streams are working together seamlessly with the same structures. And it's kind of creating this kind of black box model that the engineers can then execute and make the real engineering bill of material around that fills all that limitations and requirements for that structure. And then, of course, different kind of simulations around that. So, as a short, there is a screenshot from the system. How does it look? You can have all the elements and bits and pieces in a place. You can build the trace links between those. You can link the information and all the time trace it back where that came from. So that is one good thing. I jump this because I think there might be some questions, so leave the time to that. In the next picture, you can find kind of how these structures in the context of the product can be linked together. So in the left-hand side, you have the puzzle which are replicating the requirements. Then you have the functional descriptions. So the product needs to execute certain functions and lift the load, lower the load, move the load, whatever they need to. When you push the emergency stop, everything needs to stop. You can define it in a word that what that product does when I do this, and that is then of course helping the engineering side a lot. And then you have the logical structures. So you have the kind of hoist. It's not any specific hoist, it's just a hoist that is part of the whole crane, for example. And then you have the actual componentry side in it, that from which kind of components that hoist then will be built on, and how those are filling the whole chain of requirements. That was pretty much from my side. I would say that it's very valuable. It's easy to connect the data and collect the data, and but we need to ensure that when we start to develop and creating new products, we enable these connections and traceability back, because then we have the traceability back, and then we can have reuse and repeatability forward, because we have then the ability to learn and improve all the time. Thanks. And now it's the part of the questions, and I remember that I need to repeat those, so one sentence is enough for my short memory. And I will be here also all day, so we can discuss also later on.
Thank you, Ville. Questions to Ville? Meanwhile, you are thinking, I'll ask one. So, how you think about this scale-up issue? I mentioned that if you have like a consumer product which is maybe annually produced 100 million pieces, and will it be a problem, or is it just a daily business?
Okay, this 100 million pieces of digital twins, this is like I said, that okay, those are all the part of the product family, and we can get the data back. So I think that's something that, for example, within this project, we need to also evaluate more. We can have those individual, but is it all the time wise, or do we use edge computing and get the statistical data and utilize that compared to this fleet objective, so that how much data we store and transfer, what is the valuable data, what is wise to send over, and what that is then, let's say, heavily driven by the business value. What is the value? Because managing and sending the data around is possible, but it's not typically easy or cheap.
Thanks. Now question from audience, please. Okay.
One is that if you do this transformation, your systems kind of get a lot more complex. You start requiring a lot more like system management. Usually your engineer work gets more complex. You need more resources for both maintaining the engineering work and maintaining the systems. So it's very difficult to get this into the price of the product.
Okay. Yeah. The question was that you need to. This kind of transformation requires a lot of efforts and let's say increases the headcount in engineering and so on. I would say that you nail it in a way, but the value comes throughout the life cycle. So of course, with the digital twin, you do more earlier. You are able to validate digitally things more earlier, and later on that saves money. That also requires change of the thinking of the company management. Of course, you can see that in the new equipment side, when that part of the business then sees a little bit maybe increase of the product cost, but the spare part, service, manufacturing, they are getting the benefits of that. How to measure and make that transparent so that kind of that transition, because typically these areas are measured separately, and other one is harvesting the fruits and other one is doing the hard work, shoveling and growing the fruit. So how to make that visible? That's the also challenge of this age. How to make this, it's understandable in this way, but then when you go to and start to discuss about the hard money in the member of board or top management, then it typically can get lost a bit.
If I may add that if the system gets very complicated, it's also very difficult to understand and assess and fix without having some extra models. So there is some push also from that part. But there was a question from Tatu as well.
Yeah, just to understand the traceability requirements, what is the traceability needed for? Is it for regulation or for the actual product development part, or are there some license things?
Let's say that the question was concerning about the traceability, where that requirement comes from. Was that kind of short? Yeah. So it's actually both. There can be legal requirements coming from that you need to be able to trace back all the decisions related to this product, provide the calculations or something else. So you need to get that back and give to the authorities whenever asked as a OEM. And the second one is, of course, that if you get the data and you are missing kind of the DNA linkage, then it's typically you cannot automatically kind of improve. You need to somehow manually then connect this was actually now this R&D project and these requirements, and now they are matching if you don't have the traceability in that way. So there are kind of two ways and two values why that should be done.
Okay, let's give applauses to Ville.
Thank you.
Thank you so much. And we'll go forward in our program. Next is Juuso Autiosalo. He is the project manager for this digital twin project, and he has been also the main organizer of the event. And his title of presentation is Practical View to Project Demo and Next Steps. And then after his presentation, he will also speak about how to join the digital twin network, as we are running this project as openly as possible, and we want to have many contributors in the project also outside from the consortium. But let's start with the first topic. Please, Juuso.
Thank you, Kari. Funny thing about these digital things, I'm quite a digital guy, and still I want to sometimes have paper when I need total reliability. So we have some things to do still. Yeah. Let's go to the first slide. So I'm a doctoral candidate also here, and the working title of my doctoral thesis was Digital Twin for Industrial Products. And when I decided that quite a while ago, couple years, I thought it was definitely a too high level topic, and I should kind of find some some more exact stuff and kind of find my focus area. But now it seems that I'm on the way of going to also other than industrial products. Maybe you will hear more about it later on the afternoon. And does it even have to be products? Well, maybe not. Maybe also other things can have digital twins. But well, doctoral thesis, it's a process. So let's continue to the presentation. So what is our digital twin? And well, this DG might be using this acronym, one acronym that you could remember from today. So first half of this presentation is about kind of the data flow across the crane, and it answers to one of the previous questions from there also, and I will go through that. And then the second half is about how does the digital twin help engineering designers, and then shortly about what will we do next. So this is quite a heavy slide, but luckily the first half is all about this slide. So I will go through the components. So I have 7 components here, basically starting from the physical crane and crane PLC and industrial PC, and which has OPC server, then MindSphere gateway, MindSphere itself, then the team center, Ilmatar digital twin, then we have the actual analyzed twin information. It's kind of the user interface, and now we have developed for interface for product development or engineers, but maybe we can also later use it, provide a user interface for maintenance guys, so called. But well, the product development team might use it for developing new cranes also. So let's go to the first one. So where does the data come from? It's the physical world and the physical Ilmatar crane and its sensors and actuators, and how is it transferred here? It's basically standard industrial stuff, wires, digital and analog signals. But then we are kind of also experimenting, could we have some additional sensors? RD Velho is working on NB-IoT so that we could provide additional data from the real world. That is might be a little bit easier than connecting to all this kind of data loop that I'm presenting here. So the next, what controls the crane? Well, it's the crane PLC, or programmable logic controller. Well, and because it's controlling the crane, it's using the sensors that I previously mentioned, and that's kind of the logical place for the data flow to go forward. So there we have the data and we just feed it forwards, and this is basically standard practice in industry automation systems. We have had some ideas that could this PLC be put into cloud, and there's link to one academic paper about that, but let's not go into that too deeply right now. And by the way, about the slides, some of the stuff is meant to be kind of checked so that you can check them later, so I will not go through everything here. But so what processes data locally into kind of internet format? It's an industrial PC, so it's basically a regular component, but it's kind of more heavy duty, and it's mounted on the crane, on the cabinets of the crane. There's quite a lot of cabinets you can see today. So there's a lots of stuff in there. Yeah, and then the PC it has this OPC UA server which can transfer the data over Wi-Fi to the next component. And this OPC UA is interesting because it's a two-way connection, and could we do something else with this two-way OPC UA interface? Probably yes, but the future will show what it will be. We have actually done already something, but it's another presentation. Then what ensures security in the public internet? Well, it's a MindSphere gateway, and also MindSphere kind of provides the security so that the data is there securely. And from the MindSphere gateway, it connects to the crane through a local Wi-Fi, and it kind of then it processes data a little bit and sends it to MindSphere, and it's kind of a gateway so that it doesn't let anyone in who could do harm for the crane. Yeah, there was then going to the engineering. Ville mentioned also about this, what provides the engineering knowledge. Well, it's the Ilmatar kind of engineering data and knowledge, and we are trying to put it in the team center as well as we can. And it's kind of also this knowledge-based engineering approach. And I think this is also an interesting point. What could we achieve if all the engineering knowledge was machine readable? I think that's an interesting question. Then to the visualization, to the user side, how is the data visualized? Well, I will show it better later, so I will not go into that deeper now, but basically what we have done, we have embedded a MindSphere app into Team Center, and that's the basic point. Then how do engineers use the usage data? They can design a new crane with that. They can use the fleet data from many cranes to kind of draw assumptions, that just as Valtteri described. And for us to kind of a question for ourselves, and maybe you can also give some answers to that. or we can do that together, is that what would be the most useful ways to leverage all the data of the digital twin. We are gathering there a lot of data, and there's huge amount of possibilities. So this is the end of the first half, and back to the complicated slide. But now let's go to the second half, and ask a question. How does digital twin help engineers? First I will go through this Team Center. Probably many of you doesn't know what Team Center is, so it kind of shows the product in this case, which is Ilmatar Twin, and currently this is the as built or as maintained structure, and it shows the components as they are in the, at least almost. It's quite a lot of work to update the model to everything, but from this we'll select one. We'll select one of these which corresponds to this black trolley. It's kind of the thing that provide. Well, here we can see it. It has a hook, and it's kind of, it moves on another direction, and it lifts and lowers the hook. Then we go forward. We go to the hook and the rope reeving system, if you could say. It has basically 3 of these rope sheaves, or which all of them has this bearing that Valtteri mentioned, and they have the forces, and basically 3 bearings here, and then there one, and then we have static fixing point here, and then the motor, or where the rope goes. I don't know a word for that currently. Yeah. So how does our digital twin help engineers? It provides the data in readable format, so we can give a kind of, well, we have the analytics kind of view here, and we can draw this kind of pie chart, or we can show the usage data as Valtteri showed before, and then we still have the kind of hook here, or the 3D model. So this is not an image, it's a 3D model that you can view. This is, we can make many kind of views about the data, but this is maybe the most interesting. So it shows how the crane has been used, and this blue line is the designed lifetime for the crane, and this is how much it could be used for 200, if the lifetime was 200 years. So this is not used very much, but of course this is just one bearing that we are talking about here. Yeah. But you can see this better on the by the demo stand. Then what next? There's some keywords, and what we are doing in the next half of the project, and we also ask, do you have any ideas you could chat with us, and further kind of future directions of the digital twin concept will be I will present them in the afternoon. Thank you for listening. And do you have any questions about this presentation? I will be available also.
Which new possibilities are you most keen to see? Is it the data analysis, more into it, or is it something way out of the box?
So the question was, what are the kind of key interest points? Is it data analysis or something that we haven't yet discovered? And my personal answer is that I'm interested in everything. I think this is a very interesting topic, and I would like to do all of these, but I have to select and some aspects, and that's actually one of the points that why we are kind of calling for you to join. There's a lot of things to do, and we can't do them ourselves. Yeah. Yeah, thank you. Good question. So the question was, have we kind of combined the IoT data with some product configurators? And well, the intelligent product configurators, they were on our roadmap when we started the project, but we haven't yet quite been able to dig into that, and we haven't been able yet to kind of make that a reality, but maybe someday. Yes.
So one more question over there.
Yeah.
Is the economics of the maintenance operations somehow also linked to this? Because maintenance operations are one part of the costs during the life cycle.
Yeah. Question was pretty much about, are the maintenance operations and their costs linked to the process? And well, we haven't yet done that, but that's actually on our roadmap for this year. So pretty much we are.
I guess we have to move forward now. Thank you for so many questions, and we'll take the rest in lunch break. So yeah, if I may amend that collecting this data, there are quite many, like I would say, low-hanging fruits, and then maybe a little bit higher-hanging fruits, and we have certain targets in our research program to improve engineering design methodology and use that data. But there are quite many opportunities actually for to join and develop your, let's say, own data analytics or your own solutions, and let's go to the next. Juuso will explain how to join this digital network. But before we forget, let's give a big hand to Juuso.
Thank you very much. So, how to join the digital twin network or the DigiTwin network? Maybe more better question is why should you do it, and why do we want you to do it? And I will try to answer both of those questions. But first, what does it mean in practice? Honestly, we don't really know. It came actually it came from Business Finland. They wanted networking. That's how it came to us. But we have realized that actually it is really a good thing. And as I in the previous presentation said, we really need your help, and probably every partner will have their own story of what does the DigiTwin network, what does it mean for you? Is it student collaboration, or is it bringing some new IoT sensor to our kind of systems, physical systems? And actually I ask you, what are your needs for networking? Please, could you tell us? Because we can't read your minds, unfortunately. At least not yet. Yeah. So why are we calling you to join? It's kind of this ecosystem convergence. I took this from Jari Juhanko's slides, and this is quite a complicated picture, so I will not go through all of these, but basically there's a lot of competencies in the DigiTwin ecosystem that we need. All of these have to be kind of dealt with, and it's not sensible that one company does all of them. But we need can have some policy partner, service partner, then tech partners 1, 2, and 3, or more. And well, that's kind of the competence side. Then we also have this business side. How does the money flow? And that's kind of a little bit different story, but it's very much related. So these are pretty much almost kind of the same. When we move some competencies, we need to probably usually move some money also. That's how it goes in this world currently. So how can you join? We kind of have this 3-step program. I think you may be already on the first step of the program, kind of loose collaboration. You're using kind of the first basic information channels. You have all come to this event, but then we may have some various digital methods. For example, you could join the Slack channel and see kind of making a conversation there. Then you could have some on the second step, have, for example, some concrete prototype on our system. Of course, we need to have some business case there before you want to do it, or at least a promise of a business case. And it can be either digital prototype or a physical prototype. Yeah. Then the step 3 is kind of more tight and is definitely customized per partner, and it can be even real business already. And Aalto acts as a facilitator for the network, so we do, for example, Jari Juhanko knows pretty much what are the kind of key areas for each of our company, so he can link you to the next company. And of course you can ask me also if you have some kind of suggestion. I will kind of feed you forward to the right guys. So what can you do right now? Maybe go from loose cooperation to moderate cooperation. So could you share your perspective on digital twin on the Slack channel? What do you think? And you can join through that link, and then you can use hashtags DigiTwin and DigiTwin Demo Day, and then you can propose a meeting with Jari Juhanko. He's happy to talk with all industry guys. And one kind of interesting Jari Juhanko told me about this week is that we are in Aalto, we are starting to build a digital twin of Aalto campus. So I don't know yet what that is, but maybe we'll find out later. Thank you. Any questions?
You mentioned about the roadmap. Is it something that you can show?
Yeah, the question was about the roadmap and can we show it? We'll have to discuss, but of course we can talk about that. Yes, the basic kind of key areas that we are working on. Yes. You can also check the slide from the previous. It kind of has the key areas.
Yeah, if I may comment, I think there is no problem to sharing. We probably will need to check that what is internal information for the project, but in general, yes. There was a question. Yes, please.
Yeah, what's the incentive to join? And well, we don't have kind of one answer to that. We have to find that together. So that's why you can. I think we need to have some business case for each of you. So how can you benefit, and how can we both benefit? So finding a win-win situation, and I believe there is a lots of them available.
Yeah, if I also may comment, you probably see it better in demos, but we have some equipment in our campus which is donated by companies. The crane is in the core there, and there are quite many questions related to, let's say, data analytics, augmented reality, enhanced maintenance, lifetime prediction, maybe doing something else with, for instance, crane, which was not possible in previous. I refer what we have developed, like high precision positioning of big freight in crane, and there are kind of like different use cases, and we have built those use cases in such a way that there should be a place for SMEs or startups to find that hey, this might be cool, and then it's most likely some company to then say that hey, this is cool and please develop this to us, and then it goes to business. So we as Aalto University, of course, we probably will not make a big business, but the idea would be some type of ecosystem on the crane where there would be room for actors. but I think these are easier to understand in demos and mutual discussions than in classroom.
Yes, one aspect, basically we have too many ideas and we'd like to give them to you.
Yeah, that was a good explanation. Yeah, thank you, Juuso. So the morning agenda is there. I mean the lecture part, and now there will be food and demos in different buildings. Building and the K3 building I referred, it's Aalto Industrial Internet Campus. You will see the map behind the agenda, and all the demos except one are there. And for that one, the other the one which is not there, you will be picked in groups from that building, so you don't have to yourself leave the building. There are marks, red arrows on the snow, so that and the map, so you probably will not get lost. You should leave in this way, because the group is very big. So we should somehow divide, and there will be two group leaders. One is Juuso, and if you follow him, you will end up in food line. But please do not please do not all go to the food line, because the line will be long in that way. Then there is another group leader, Joel Mattila. Sorry, please stand up. And if you follow him, you will go to demos. And now I hope that you could somehow self-organize yourselves so that it goes half-half, because otherwise the lunch will take a long time and you will just be standing in the queue. And yeah, excuse us, our premises are a little bit small for this of a big audience, so when you have taken your lunch, try to kind of like nicely go away from the table, because because it will be quite stagnated. So the other demo I mentioned, it's called A-Router, and you will be picked up from Aalto Industrial Internet Campus. And you'll have a list of demos also in the agenda paper. And the signs I said, then I'm told to say about the hashtag demo day channel in Slack. Juuso already mentioned it. There is another hashtag on the table to Twitter. And then finally we are continuing here 1 p.m. 1:00, and then Juuso will give a deeper dive to digital twin. But at this stage, please somehow organize yourself following Joel or Juuso. Bon appetit and have fun in demos.